Welcome again to my channel. Today our topic will be the time value of money, specifically the future value. In order to master the future value, you need to answer these three important questions. Number 1, what will be the future value of an investment if one will invest this much now or every period at a specified growth rate? So in here, the amount of money to be invested and the growth rate are given. You are to find out the investment value in the future. The number 2 question is, how much should one invest now or per period if one wanted this much in a specified period and specified rate? So here, the desired future value of money and the interest rate is given. What's missing is the amount to be invested. In number 3, how much is the interest rate should the present investment grow to get the desired future value of the investment? In simple terms, the amount available for investment and the desired future value of the investment is given. You just need to find the interest rate so that your present investment will really reach the desired future value. The question number 1 has already been answered in video number 1. The link is in the description below. Check it out first before you continue with this video, and for those who have already seen the video number 1, let's answer question number 2 and question number 3 right now. Let's try to answer the second question by an illustrative problem. But before we go to that, I would like to highlight something that we have learned from the last video. These are some formulas to get the different future value factors. If we are to have one-time investment, we are gonna use 1 plus I raised to the power of n. And then, if we have multiple uniform investments at the end of each period, we're gonna use the 1 plus I raised to the power of n pa din. However, we're going to add two elements, which are the minus 1 and the over I. But if we are going to have multiple uniform investments at the beginning of each period, we're going to follow this one. However, we are going to add another two elements, which are the plus 1 on the n and as well as the final minus 1. But let me remind you again that please see video number 1 first to fully understand this video lecture. The link again is on the description below. So that's it for the highlights from the past video. Let's go now to the illustrative problem. Mr. A wants to have 3 million in 3 years because he wanted to buy a car. The interest rate is 10% per annum. How much will he invest? So there are two cases here. So in the first case, we are to assume that Mr. A is to invest one time big time immediately today. So we can have a timeline analysis for 3 years. So after 3 years, we have the desired future value of 3 million. We also know of the 10% rate because it's given. In the past video, we start right here in the beginning and then we multiply the amount of our investment at 1 plus interest rate. In this case, we have 10%. So we have 1.10. Why 1.10, sir? Again, the 100% investment is represented by 1 here, and then we add the interest rate, that's why it's 1.10. In this particular case, since we are going to start here, the opposite of what we've learned in the past, so instead of multiplying, we are going to divide 3 million by 1.10, and we're gonna get 2727272.72. This amount will then be again divided by 1.10 and we're gonna get 2479338.84, and lastly, we are going to divide it with the last 1.10, that gives 2253944.40. That means, if you want to have 3 million after 3 years time, and you wanted to invest at one time big time immediately today, you should invest this amount, 2253944.40. We can also have the shortcut or formula, which is investment times 1 plus I raised to the power of n equals the future value of the investment. We used 1 plus I raised to the power of positive n because there is only a one-time investment mentioned in this case, number 1. So let's substitute. The investment is missing, right? But the interest rate is given, so we can get the future value factor from 1.10 raised to the power of positive 3. And since the desired future value is given, the 3 million, then there is only one unknown. To get that, we have to simplify the equation first by getting the 1.10 raised to the power of 3, and we have 1.331. So, in order to get the unknown, you just have to divide the 3 million with 1.331, and then you're gonna get the amount of investment, which is very the same with what is our solution on the timeline analysis. To master the topic, let's have the case number 2 and assume he will invest every beginning of the year starting immediately. So let's go to the timeline analysis. Of course, you're gonna invest 3 times. One here, another one here, and another one right here. And after 3 years, we still want to have 3 million pesos because we want to buy a car. Now, we are still going to use the 1.10 because the rate of return is unchanged. So, in order to get the answer, divide 3 million with 1.10. So, we have 2,727,272.72. And we cannot go back further, because we don't know the amount of this one, and this one. So, in cases like this or problems like this, the timeline analysis cannot be able to get the answer. So, what do? Of course, we use the shortcut or the formula, which is investment times 1 plus I raised to the power of n. But since it talks about multiple investments, you have minus 1 and over I. And since, according to the case, the investment is every beginning of the year or every beginning of the period, we need to add other 2 elements. We have plus 1 on the n and the final minus 1. So investment times this one equals the future value. So let's substitute. So the investment is unknown, but we can get the future value factor by getting 1.10 raised to the power of positive 4 minus 1 over 0.10, and we have the final minus 1 equals the desired future value of 3 million. So, investment, if you're going to summarize this one, times 3.641 equals 3 million. And then if you want to get the unknown investment, you just have to divide 3 million by 3.641, and you're going to get the investment is equivalent to 823,949.46. So let's check if ever your investments of 823,949.46 will really become 3 million at the end of 3 years. So let's have your first investment right here, the second investment will be here, and the third investment will be right here. So let's start. 823,949.46 times 1.10, you're gonna get 906,344.41 plus 823,949.46, you're gonna get 1,730,293.87. You multiply that again by 1.10, you're gonna get 1,903,323.26 plus 823,949.46. Then you'll have 2,727,272.72. And lastly, you multiply it with another 1.10, that gives 3 million really. So that's the proof. So meaning, if Mr. A wants to have 3 million after 3 years and he plans to invest every beginning of each year, then his investment should be 823,949.46. So, what if the specified rate is absent, or you're gonna find the rate? That is up next. We are now on the last part of our video lecture, which is focused on answering the question, how much is the interest rate should the present investment grow to get the desired future value of the investment? In order to understand this, let's jump to the illustration. So we have Mr. A wants to have 3 million in 3 years to buy a car. So all of the problems in this video lecture are quite similar. So A can invest 230,000 per quarter. What should be the rate of return of the investment in order to reach the targeted 3 million after 3 years? Let us have the timeline analysis. However, let me tell you in advance that the missing rate can't be found using the timeline, but we are still going to have the timeline to illustrate the pattern of your investments. Like for example, in year 1, you're going to contribute 230,000 at the end of quarter 1, as well as at the end of quarter 2, quarter 3, and quarter 4. The same pattern will be used by the year 2, and of course, at year 3. However, at the end of the third year, we should be having 3 million. We are expecting to have 3 million as the value of the investment. So aside from this pattern, we are going to use this timeline analysis to check our answer later. The important question is, how do we get the missing rate? So to get the missing rate, we need to do two things. The first one is the trial and error, and the second one is the interpolation. So first, I'll explain the trial and error. This particular step has two requirements. So requirement A is to get the appropriate formula in getting the future value factor. We have three choices as discussed earlier, but since our problem is a case where there are multiple uniform investments of 230,000 at the end of each quarter or each period, then we use 1 plus I raised to the power of positive n minus 1 over I. And the second requirement is to set the objective, which is, in this case, is to know the rate for the investment to reach 3 million after 3 years. After those requirements are set, the trial and error will follow. For example, we want to try 10% per annum. So we have to use that in the appropriate formula mentioned under requirement A. So we have 1.025 raised to the power of positive 12 minus 1 over 0.025. Sir, why is it 1.025? It was supposed to be 1.10 because the interest rate is 10%. Guys, the problem stated quarterly, right? So we're gonna use 10% per annum divided by 4 quarters, which is 2.5%. That is why we used 1.025. And before you ask again, the n is actually 3 years times 4 quarters, so we have 12 periods. So I hope that's clear. If we summarize this, then we're going to get 13.79555.3, and you multiply that with the quarterly investments of 230,000, then you are going to get 3,172,977, which resulted a little bit higher than what we are aiming for, which is 3 million. So let's try a rate that is lower than 10% so that we can have an answer lower than 3,172,977. So let's try another. Let's say, for example, we have 5%. So remember that we are not going to use the 5%. We need to divide the 5% with 4 quarters so that we can get the quarterly rate. So if we are going to apply that one, we have 1.25%. So 1.0125 raised to the power of positive 12 minus 1 divided by 0.0125. So we will have 12.8603361. You multiply that again with the quarterly investments of 230,000, then you are going to get 2,957,883, which is slightly lower than the 3 million that we are aiming for. So that's the end of the trial and error. Actually, you can try as many times as you like, but for the trial and error to end, remember to pick the two rates which will result nearest to the desired future value, which is in this case the 3 million. So just like these two tried rates. And number 2, you need to remember that it is much better for one of the trial rates to result in a slightly higher amount than what we are aiming for, just like this one, and the other trial rate should result in a slightly lower value than the desired future value, just like this one. So that's all for trial and error. Let's go to step 2, the interpolation. So the first step is to organize the rates and the resulting figures. What do you mean, sir? So a while ago, we tried 10% and 5%. So you put it right here, and on the opposite side the resulting values. So when we tried 10%, it resulted to 3172977, right? And when we tried 5%, we got 2957883. Next is you need to put the 3 million in the middle, as well as the x representing the unknown rate. And then we find x. The question is, how do we do that? Focus on the tried rates. So we have 10% and the 5%, and then get their difference, which is 5%. So if we express that in an equation, it means to arrive at the second tried rate, you're going to deduct 5% from the first tried rate. So you need that equation because if you wanted to find the effective rate, you will follow the same, which is 10% minus 5. However, the 5 will still be multiplied with a fraction. The question is, how do we get the fraction? In the value section, the first minus the second value, the difference in absolute values, absolute value meaning we don't care if it is positive or negative, will become the numerator. So in this case, we have 3,172,977 minus 3 million. So we have 172,977, the numerator, while the denominator is the first value minus the third value, which is 215,094. So simplifying the equation, 5% times this fraction, you are going to get 4.02. So we have 10 minus 4.02, then we're going to have an effective rate of 5.98% or 6% per annum. And if you wanted to convert it, you have 1.5% per quarter. Sir, what if we choose other trial rates? Like for example, instead of using the 10% and the 5%, we are going to use 8% and 4% here. So will we arrive at the similar answer? Of course, if you follow the steps. So you can try it if you want to. Sir, we want proof. Okay, let's check if the 1.5% per quarter is really correct by using the timeline analysis that we have prepared a while ago. And if it is correct, then after 3 years, the value of the investment should become 3 million or near 3 million. So let's start. Let's multiply our investment with 1.015, applying the 1.5% per quarter. So 230,000 times 1.015, you're gonna get 233,450 plus 230,000. So that's 463,450. And then this 463,450 times 1.015 again, then you're gonna get 470,401.75 plus 230,000, you have 700,401.75 times 1.015, you're gonna get 710 plus 230,000, that's 940,907.78. So that's on the first year. On the year 2, the 940,907.78, that's the end of year 1, will become the beginning of the year 2 times 1.015, you're gonna get 955,021.39 plus 230,000, that's 1,185,021.39 times 1.015, 1,202,796.71 plus 230,000, we have 1,432,796.71, and then again multiply it with 1.015, we have 1.54 plus 230,000, we have 1,684,288.66. you continue multiplying, and then you're gonna get at the end of the second year 1,939,553. On the year 3, we have 1,939,553 from the year end of year 2 times 1.015, you're gonna get 1,968,646.30 plus 230,000, and then we're gonna get 2,198,646.30 times 1.015, we have 2,231,626 plus 230,000, we have 2,461,626 times 1.015 plus 230,000, we're gonna get 2,728,550.39. And lastly, times 1.015, we're gonna get 276,9478.64 plus 230,000, that is 2,999,478.64. The value is slightly off, I know, but that is because of rounding of factors. So 299,478.64 has a difference with the 3 million. But if you want to be strict, then interpolate again and come up with trial rates which will result to nearest to 3 million. For example, this 10%, you can change this into 6%, and instead of putting 3172977, so you're gonna put here the 299478, and instead of using 5%, for example, you can change this to 6.10%. It's really up to you, but follow the steps, of course. So that's it. So before we end this though, I have a problem that you need to solve. I will announce the answer in video number 3 about the time value of money, discussing the present value. So this is the problem. You want to have 1 million at the end of the year. You decided to invest 230,000 per quarter. So what should be the annual interest rate that will turn the 230,000 into 1 million at the end of the year? And that's the end for this video lecture, and I hope it helped. If it did, please click like and subscribe and share, and don't forget the notification bell to be updated on my next videos. And by the way, if you're wondering about the format of my videos, I made it like this so that if you wanted to copy the important details or you wanted to make a summary, you can do so, because the risk of bad penmanship is eliminated.